Welcome back to the course on agricultural economics. Today we will be exploring the emerging technologies in agriculture. In previous sessions, we discussed about the role of technology in agriculture, its different phases, green revolution and mechanization in agriculture. Today we will be discussing about different emerging technologies in agriculture, how and why these emerging technologies are important for Indian agriculture, its challenges and future prospect. So, dear learners, it is well known that technology has significantly shaped the way we live, we communicate, we travel and interact in our modern society. Its rapid advancement has had a profound impact on various industries, and so does in agriculture. Agriculture is the mainstay of many developing countries, and it is undergoing a transformations due to digitizations. So when we talk about emerging technologies in agriculture, the term precision agriculture comes to our mind. So what is precision agriculture? The precision agriculture means, in simple words, it is the use of technology for improvement of crop yield and management. Precision agriculture is an information and technology-based systems that uses various sources of data such as soil, crop, pest, humidity, yield, nutrient, temperature, moisture for sustainability, optimum profitability as well as protection of the environment. So now if we see the agricultural sector, technology is an integral part of the entire systems of agricultural production, right from the crop planning and land preparation to the post-harvest activities as well as marketing. So digital technologies for data collections, storage, analysis and sharing open up a vast opportunity for the implementation of emerging technology in both pre-harvest as well as post-harvest segment of the agricultural value chain. As we already discussed in the previous session about the agriculture 1.0 to 4.0, now this is the era of agriculture 4.0. So in this era we can mention about certain emerging technologies such as IoT, Internet of Things, Big Data Analytics, Artificial Intelligence, Unmanned Aerial Vehicles, Blockchains. These are certain boomed technologies in the field of precision agriculture. So with the help of these technologies, it became easier to monitor crop health, identify in-season nutrient deficiency, help in crop selection, efficient utilization of resources, monitoring crop growth, monitoring the parameters of soil health, and also in optimization of storage as well as time-sensitive local, regional, national and international agricultural supply chain. Now coming to the Indian scenario. Now let us have a discussion how and why these emerging technologies are important for shaping the future of Indian agriculture. So we can discuss this with certain issues. With certain issues we can explore the niche of technologies in Indian agriculture. Agriculture, a cornerstone of the economy and a support of the nation for more than half of its population. And this sector faces many unprecedented challenges that require the adoption of emerging technologies. As per the report of Ministry of Agriculture and Welfare of Farmers 2023, as of now, agriculture continues to involve approximately 42% of the Indian workforce, and at the same time it contributes around 18% of gross domestic product of the country. Despite its fundamental role in assuring food security and economic stability, the sector is affected by inadequacies, obsolete or age-old farming practices, and vulnerabilities as a result of climate change, resource depletion, and demands in the evolutions of the market. Again, if we see the Indian agriculture, it has diverse agricultural practices across many regions, which actually poses challenges and opportunity. Now, let us look into the Indian agricultural landscape. It is highly heterogeneous in nature, with more than 6 lakhs villages and a myriad of cultivation systems ranging from rice in the oriental region to cotton in the west. So this diversity requires personalized approaches to modernize agricultural techniques. However, Indian agriculture is characterized by small and marginalized farmers, and it is seen that they often lack access to the modern tools and technologies, and it results in aggravated productivity and sustainability problems. So these farmers generally operate under limited financial resources, inadequate, actually they don't have much knowledge of contemporary agricultural practices, that is modern agricultural practices, which highlights the urgent need for innovation. Then another pressing issue is the change in climate, which raises a significant threat to Indian agriculture. The erratic monsoon, the growing temperature, and the increase in the occurrence of drought and floods are remodeling the agricultural calendar. It has changed the agricultural calendar, that is, the changes in the sowing season and sowing times. Consequently, there is an imperative to adopt technologies that not only improve productivity but also improve resilience to climate changes. Then next issue is the shortage of resources, particularly in terms of water and soil degradation. Because of continuous monocropping and excessive use of fertilizers, further complicates the sustainability of Indian agriculture. The country depends largely on groundwater for irrigation, and excessive extraction has led to a decrease in water tables in many regions. The situation requires the implementation of efficient practices in possibly through technological innovation than innovative technologies. Precision irrigation, for example, uses advanced sensors and data analysis to apply water where and how for the growing of crops. Next is the food security. This is another cornerstone of national policy, which actually requires a solid response to meet the demands of growing population that is expected to increase by 2050. So conventional agricultural methods may not be enough to meet these demands of the future. Therefore, technologies that can increase crop yields to improve nutritional quality are critical to ensure that the needs of the populations are satisfied sustainably. Another issue in the agricultural sector is the migration of young people to the cities, leaving behind the aging farmers who actually continue to work in their fields well into their 60s, 70s, even in 80s. And this raises the question of whether now is the right time for IoT, that is Internet of Things, and blockchain to collaborate in the field of agriculture. So by implementing this technology, there is a potential to attract migrant workers back to the agriculture by providing them with opportunity to contribute technology to this sector. India, although it is one of the largest producer of agricultural products like pulses milk in the world, is faced with significant challenges to convert this high production into substantial export value. A leading factor contributing to this gap is the normalization of quality. So what happened? In case of quality, the absence of strict quality control measures often results in agricultural products that do not actually meet the international market standard. In addition, these losses of the value chain represent a significant obstacle in improving agricultural export. These losses occur at various stages of production, treatment and distribution, leading to a reduction in the volume and value of the exportable excess. So, technological advances, particularly in blockchain and electronic traceability systems, have become possible solutions to improve the integrity of the supply chain and consumer confidence. Blockchain technology, for example, has been proposed as a means to guarantee traceability in agricultural supply chain, allowing interested parties. This innovation is not only a response to need for farmers to adopt best practices to increase the commercialization and competitiveness. So, if we see the need of emerging technology in agriculture, in Indian scenario, the state of Indian agriculture, marked by significant diversity and critical challenges, needs an urgent transition towards emerging technology. The integration of precision agricultural methods can give practical solutions to improve productivity, address the scarcity of resources and ensure food sustainability. Emerging technologies such as precision agriculture, remote sensing, IoT, artificial intelligence and analysis offer promising solutions to address these challenges. And by providing real-time data and promoting a better decision making, these technologies can help farmers to minimize the waste and ultimately increase the crop productivity. So these are certain issues on the basis of which we can have a pictures of why and how actually emerging technologies are important for Indian agriculture. Now let us discuss some example from different strata of the country. Several regions in India illustrate the successful application of precision agricultural method, which show their potential to transform the agricultural landscape for small farmers. For example, in the Punjab region, farmers who use precision agricultural technologies such as soil moisture sensors and automated irrigation systems reported performance increase up to 30% and significant saving in water use. Similarly, an initiative in Andhra Pradesh that uses satellite images and remote sensing to guide farmers in times of optimal plantation has shown a better crop production and effective pest management. Now, coming to the challenges. Everything has both potential benefits as well as challenges, and thus the adoption of emerging technologies in Indian agriculture faces many challenges that significantly prevent their potential benefit. First, we can cite the infrastructure restriction, which remain a critical barrier. A vast proportion of the agricultural scenario of India is characterized by insufficient access to reliable electricity, irrigation system as well as internet connectivity, which are essentials for the actually effective implementation of precision agriculture technology such as ground moisture sensors and data analysis platform. In addition, a wider spread lack of technical knowledge among farmers is a significant obstacle. It's obvious that many of our farmers, particularly those in rural and semi-urban areas, are not properly trained to understand or operate advanced digital tools. Thus, there is a knowledge gap which is even more aggravated by generational division. Means Younger farmers usually have better technical skill than the older farmers. But it is also interesting to see the record that points out the absence of formal educational programs adapted to the agricultural sector led to a dependence on traditional agricultural method, and thus it limits the exploitation of innovative solution. Then next is the financial limitation, which play a fundamental role in limiting to determine the adoption of emerging technology. Most farmers, what happens in India, operate on fine margins and usually do not have access to the credit needed to invest in high-tech equipment. The cost associated with the acquisition and maintenance of precision agriculture technologies can be excessively high, and as a result of this, what happened? Many farmers opt for cheaper traditional methods. And additionally, economic disparity in agricultural community means that innovative technologies can benefit mainly rich farmers, and it worsens the existing inequalities in the sector. Next is the policy related barriers, which also prevent the integration of emerging technologies in Indian agriculture. Although the government started several programs to promote intelligent agricultural techniques, inconsistency in implementing policy and inappropriate support for small farmers usually result in disappointment with this initiative. Another example is automation has shown considerable perspective to transform Indian agriculture. The introduction of automated drones and machinery can simplify various cultivation process from plantation to collection. Various studies reported that the efficiency of use of drones in orchard reporting a reduction of 40% of the cost of the work. Another pivot case study involves the use of remote sensing technology in Punjab region, where satellite imagery has been used to facilitate effective water management and culture monitoring. More specifically, the Indian Space Research Organization, in short it is called as ISRO, who has collaborated with the local agricultural cooperatives to deploy satellite data to access the humidity of the soil and health of the crops. This innovative application has enabled farmers to make informed irrigation decisions, resulting in water saving of around 20 to 30%, while at the same time it improved the basic crop yields, such as in the case of wheat and rice. The integration of remote sensing not only optimized the use of entries, but it has also led to more resilient agricultural practices in the middle of increasing climate variability. In the state of Maharashtra, the implementation of tractor guided by GPS inaugurated a new era of mechanization and efficiency in the cultivation of sugarcane. Using GPS technology for mapping and farm in the field, farmers were able to reduce overlapping during the planting as well as spraying processes. This precision has reduced operational cost by around 15% and improved culture uniformity. In addition, data analysis systems integrated into these tractors have enabled farmers to collect performance data in real time, promoting adaptive management strategy response to the variability of the field. The successful integration of this technology has been essential not only in improving productivity but also in strengthening economic viability within the agricultural communities of small operators. A notable initiative at Tamil Nadu presents the application of drone technology for culture monitoring and pest management, contributing significantly improving yields. It is the air imaging and multispectral analysis, with the help of which farmers have acquired an overview of infestation of pests and the state of the health of plants. This has notably reduced the need for chemical pesticide as well as fertilizer application by allowing targeted interventions. So another case study is from the Karnataka, which actually illustrate the impact of data analysis platform to facilitate precision agriculture effort among small farmers. By mobilizing mobile application that compile localized weather forecast, soil health data and market trends, farmers have improved their decision-making processes concerning sowing dates and allocation of resources. These applications have enabled agricultural practices timely adjustment, which gives an average increase in productivity by 30% per hectare. So, these illustrated case studies of various geographic regions in India collectively highlight the potential for precision agriculture method. The interaction of remote sensing, GPS technology and data analysis has catalyzed significant progress in terms of productivity, resource and environmental sustainability and resilience of the Indian agriculture. The vital to integrate emerging technologies in Indian agriculture has become increasingly evident as highlighted through this discussion. However, it is equally clear that several challenges make it difficult to adopt these technologies. So, a call to support policy structure is critical. Policy formulation should prioritize the establishment of initiatives and incentives that promote development and dissemination of agricultural technology. This includes not only financial assistance for small farmers, but also facilitating training programs designed to improve digital literacy as well as technological know-how. So, looking to the future, it is crucial that more research is needed in case of emerging technologies that not only increase the productivity but also emphasize sustainability, resilience and economic stability in agriculture.
Indian government recognizes the transformative power of AI in agriculture. The Ministry of Agriculture and Farmers' Welfare is leading the charge with several initiatives. These initiatives aim to make AI accessible to farmers across the country, bridging the digital divide. One such initiative is the Kisan-e-Mitra chatbot. This chatbot provides farmers with instant information on a wide range of agricultural topics. Another key initiative is the National Pest Surveillance System. This system uses AI to detect pest attacks early on, enabling timely intervention and preventing widespread crop damage. Imagine a farmer in a remote village needing urgent advice on pest control. He can simply ask Kisan-e-Mitra, a chatbot available on his mobile phone. This chatbot, developed by the government, is like having an agricultural expert in your pocket. Kisan-e-Mitra can answer questions in multiple languages, making it accessible to farmers across India. It can provide information on weather forecasts, crop prices, government schemes, and much more. This easy-to-use technology empowers farmers with knowledge at their fingertips. Pests and diseases can destroy entire crops, leading to huge losses for farmers. The National Pest Surveillance System, powered by AI, acts as an early warning system. It analyzes data from various sources, including satellite imagery and weather patterns, to predict pest outbreaks. This early warning gives farmers time to take preventive measures and protect their crops. The NPSS is a shining example of how AI can safeguard our food security and improve the livelihoods of farmers.
This is going to blow your mind. Tech is transforming Indian agriculture in ways you wouldn't believe. Imagine drones buzzing over fields, spraying pesticides with pinpoint accuracy, and farmers using GPS-guided tractors to plant crops with zero overlap. Sounds futuristic? It's happening now. In Maharashtra, precision breeding methods are boosting crop performance by 30% and cutting water use by 20%. Automated drones are reducing labor costs by 40%, making pest management a breeze. Think that's impressive. Nanotechnology is taking it to another level. Nanofertilizers target plants directly, minimizing waste and cutting costs while boosting yields. And in Punjab, ISRO's satellite imagery helps farmers save up to 30% water while increasing crop yields. GPS-guided tractors in Maharashtra? They're slashing operational costs and boosting efficiency. The future of Indian farming is tech-driven, sustainable and super productive. From drones to nanotech, these innovations are not just transforming agriculture, they're transforming lives. So, what's next for Indian farming? The sky's the limit. The World Economic Forum's AI for Agriculture Innovation, or AI4AI, is making waves in Indian agriculture. This initiative, led by the Centre for the Fourth Industrial Revolution in India, is using artificial intelligence to create smarter farming solutions. One standout project under AI4AI is called Sagu Bagu. It's a pilot program in the Khammam district of Telangana, backed by the Bill and Melinda Gates Foundation and implemented by Digital Green. This project has already made a world of difference for over 7,000 chili farmers. Check this out. Sagu Bagu has increased chili yields by 21%, reduced pesticide use by 9%, and cut down fertilizer use by 5%. And the best part? Farmers are seeing an 8% rise in unit prices and an income boost of over 66,000 rupees per acre per crop cycle. That's practically doubling their income. But it doesn't stop there. The Telangana government has expanded Sagu Bagu to include 500,000 farmers, covering 5 crops across 10 districts. They're also providing AI-based advisories, soil testing, produce quality testing, and even e-commerce services. It's incredible how technology is reshaping agriculture. The initiative addresses key challenges like fragmented infrastructure, high costs, and limited access to data and expertise. And it's not just about India. The knowledge gained here is being shared globally, helping other countries.
So with this, I come to the conclusion of today's sessions. Thank you.